Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians! Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And we make the case that mathematizing is not about mimicking steps or memorizing facts, but it's about thinking and reasoning, about creating and using mental mathematical relationships. We take the strong stance that not only are algorithms not particularly helpful in teaching, but that mimicking algorithms actually keeps students from being the mathematicians they can be. We answer the question, if not algorithms and step-by-step procedures, then what?
So if you've been around for a while, or you've been really good about going back and listening to older episodes, you know that in episode 5 and 6, those are the episodes where we talked about your thing, right? The development of mathematical reasoning.
Yeah.
And in those episodes, we described the progression and we talked about the graphic in detail and kind of highlighted some important points for each of those domains. We also shared that Pam created a workshop all about her progression, and it is absolutely free.
Dun, dun,
So
dun.
we decided that it's been a year, right? So we decided that we wanted to revisit and dive deeper into what we call the DMR, the development of mathematical reasoning. So right now, I'm going to say that if you have not listened to episode 5, you might want to pause now, go check out episode 5 to get a little bit of intro, and then come back and join us.
Yeah, totally.
Okay.
It's short,
Yep.
right? But it would give you some important things that we're not going to repeat today.
Yep.
So that would be kind of important.
Okay. So Pam, you talked briefly before about why this progression, just really briefly. And so I'm going to ask you again to share briefly what brought this up for you.
Well, right now I want to talk about what brought this up just recently. So why are we
Okay.
thinking about it right now? In a huge way, it's fascinating to me. I talk to a lot of teachers, work with a lot of adults that are working with kids learning more math. And often teachers will say things like, yes, it's so great to let students solve the problem in their way. Yep, I've got students who struggle, and it's wonderful that they can find the answer in their way, the way that makes sense to them. Because Pam, it's okay if they don't do it the right way, quote unquote, because if it makes sense to that student, then that student should be allowed to do it that way, their way. So yes and no. I'm always a little bit like I want to keep listening when teachers say that, because I have this major concern. And it might not surprise you that I'm kind of about a little yes and no, because often I'm a little bit yes, but let's really think. But it also might surprise you that I'm not just carte blanche. I'm not just like absolutely saying, yeah, like if that kid can do it that way, if that's the way they understand it, absolutely, that's their way, and let them do it. Because I am a huge advocate for student identity and making sure the kids really feel like they're mathematizing and using what they know. But I want to parse it out. So to be clear, it cannot be about getting answers any old way and that's good enough. It must be about helping students develop as more and more sophisticated thinkers using more and more sophisticated relationships. Solving problems using what a student knows, the way that comes naturally to them, is so important. It is a necessary first step, but it cannot be the end result. We need to find out how kids are thinking. That has to be, we have to do that. We have to hear where they are, what they're thinking, but then plan to help them develop from there.
Yeah, that's so good. So we both listened to the previous episodes and realized that how you speak about the progression, the development is a little different a year later, right?
Hmm.
Like
Hmm.
the big stuff is still remains, but you've added to it and clarified your thinking a little bit. So start us off a little bit about what you would want to add on today to that work.
Excellent. So one of the major points of that development is that there are these, there's a progression, and
Hmm.
that levels or domains of thinking get progressively more and more sophisticated. And in order for kids to think in those most sophisticated domains, like functional reasoning or proportional reasoning, then we need to build on that. We need to have kids reasoning successively more sophisticatedly.
Right.
And so there are those levels that build on each other. There are also some kinds of reasoning that we put along the bottom of that graphic that are more longitudinal
Hmm.
in what's the word I want? In by nature. The nature of them is that they're more longitudinal. They're not necessarily dependent on the other levels of reasoning. We want to start developing spatial reasoning. That's one of them. We want to start develop spatial reasoning early, and we want to progressively get more sophisticated spatial reasoning. And we want to develop, so we got spatial reasoning, statistical reasoning,
Algebraic,
and what was the other one?
algebraic reasoning.
And algebraic reasoning. Oh, come on, Pam. And we want to develop algebraic reasoning early, and then get progressively more sophisticated in that kind of reasoning.
Right.
Early, when I put out the development graphic, I only had the two, algebraic reasoning and spatial reasoning, and I didn't have statistical reasoning yet. And then Joe Bowler, not too long ago, came out with a lot of discussion about number and about data, and how we can use data to really help us think and reason more sophisticated about a lot of things. And I was like, oh yeah, statistical reasoning, that's longitudinal as well. I think that also belongs with algebraic reasoning and spatial reasoning
Hmm.
along the bottom. So we added that to the graphic. So if you've ever seen one of the earlier versions of the graphic, just add that little bit of statistical reasoning along the bottom, and that's a helpful addition. A couple other poignant things that we could add, some extra details, it didn't actually change the graphic, but some details that I hear teachers sort of talking about, and I just kind of wanted to add in today's episode, is that we have counting strategies, counting thinking, counting reasoning is kind of the first domain that kids learn about, and then that moves to, we want to get more sophisticated with additive reasoning, and then we want to get more sophisticated with multiplicative reasoning. Sometimes teachers will look at additive reasoning and they'll say, where's subtraction? Oh, yeah,
Hmm.
subtraction lives in additive reasoning.
Right.
Similarly, teachers will say, where's division? Well, division lives in multiplicative reasoning. If I'm really reasoning about division, then I'm reasoning multiplicatively about division. If I'm reasoning about subtraction, then I'm reasoning what we would call additively about subtraction. So those operations live in those domains. So it just so that you haven't, if you didn't see them and you're wondering where they are, they sort of live in those domains.
Yeah.
So one other detail is, and I actually mentioned this in episode 5, that then it has come up enough since then that maybe it wasn't quite clear. People need to hear it again. That you don't necessarily leave a level of reasoning behind. So what I mean by that is, if you are solving, say, a multiplication problem, inside that multiplication problem, while you are thinking and reasoning multiplicatively, you're probably going to do some addition subtraction. You're probably going to use some additive reasoning. Well, I want you to, when you're doing that addition and subtraction inside that multiplication problem, I want you to absolutely use additive reasoning to do that addition and subtraction. I don't want you using counting strategies to solve that addition part or that subtraction part within that multiplication problem. But the multiplication part of the problem, I don't want you using additive reasoning to solve. I want you using multiplicative reasoning. I want you thinking in terms of bigger chunks of numbers than one group at a time. But I might do an over strategy for that multiplication problem. I might think about something where I'm thinking about I don't know, 9 times something. Instead of thinking about that, I think about 10 times that thing. Well, then I need one less of the thing. So I've got to do a little subtraction. Well, in that subtraction, think as sophisticatedly about that subtraction as you can. Think additively about it. Don't count by ones. Don't use a counting strategy, counting by ones. But at that idea of using 10 things to subtract just one of those things in order to find 9 of those things, that's multiplicative reasoning. So I'm using multiplicative reasoning when it's called for. That doesn't mean that I leave additive reasoning behind. If
Yeah.
I am similarly, if I'm thinking about proportional reasoning, a proportional reasoning problem, I'm probably going to use multiplicative or multiplication in that problem, but I don't want to just use sort of simple multiplication in order to solve a proportional reasoning problem. I want to be thinking and reasoning proportionally and then say to myself, ooh, how do I use that to solve this? Ooh, I might do some multiplication to do that. I don't want, as I think about that, I don't want to go back and then skip count to solve that multiplication problem inside that proportional reasoning problem that I'm doing. I want to think as sophisticated as the problem calls for. Why? Why? Because it's all about building reasoning, building more and more sophistication in kids' brains, literally making their brains more dense, having more relationships, being able to grapple with more simultaneity. And the big point that I just wanted to add is so you don't leave reasoning behind. You don't then never add again just because you've moved on to a more
Right.
sophisticated reasoning.
Right.
Yeah.
So I'm glad that you brought up a couple of specific examples just now, and I want to take a minute to do that some more because it's something that we left out of the earlier episodes, the first
Yeah.
few episodes.
Kim and I were
So
laughing after we went back and listened to episode 5 and 6. We were like, oh, we didn't give very many specific examples. Huh,
so let's do
oops.
that now, right? Let's do it now. Let's get specific and give some examples.
Okay, cool. So let's just a random addition problem. Kim, if I were to ask a kid, I've got 5 gumdrops and I'm going to give you 7 more gumdrops. How many gumdrops do you have? What might we see kids do or think about?
So if they're using a counting strategy, first of all, we often think about the answer, right? As
Mm-hmm.
teachers, and hopefully your listeners are moving away from that. But a lot of times we're focused on the answer, so we would hear 12. But we're suggesting that we need to ask how students are thinking about that problem. We need to ask them, what were you thinking? And so if the problem was 5 plus 7,
Well,
we
and
might.
to be really clear, it's not that we don't need the answer 12,
Sure, of
right?
course, right?
It's
But
just that
that's a
we don't want that
given.
to be, we
Right.
don't want that to be the only focus.
Yeah,
Yeah.
absolutely. Thanks for
Yeah.
that. So we might see or hear kids verbalize how they thought about that, or maybe we start seeing some fingers or they're like a head bob, right? So
Mm-hmm.
if a kid says 5, 6, 7, 8, 9, 10, 11, 12, maybe whisper fingers. Or even if they start with 7, starting with a bigger number, 7, 8, 9, 10, 11, 12. That counting by ones is a counting strategy because that's kind of the definition of a counting strategy,
But
counting by ones.
Kim, they were solving an addition problem. They were solving 5 plus 7.
Mm-hmm.
They're not.
Yeah.
That's not a counting strategy. If they're
Right.
solving 5 plus 7,
Right.
or is it?
Right. So we could have kids using an additive strategy to
Yeah.
solve
So what would
5
that
plus
look like?
7.
Different. What would that
Different.
look like differently?
Okay. So that might be a kid knowing 5 plus 5 is 10 and thinking of the set, breaking up the 7 into a 5 and 2, and then knowing embedded in that 7, I've got a 5 and 5, which is 10, and then 2 more, which is 12. That's a way
Yeah.
they could be thinking additively.
If they're thinking about 5 plus 7 additively instead of
Mhm.
counting by ones using that less sophisticated strategy
Right.
of counting strategies. Give me another one. I'm curious. 5 plus 7. Give me
Okay.
one more additive strategy.
So they might start with 7 and know that that other 5 has a 2 and 3 in it. So start with 7 and add 3 more to make 10, and then that leftover 2 to make 12.
Totally cool. And it's kind of a get to a friendly 10 strategy.
Mm-hmm.
Nice. And so those 2 strategies, thinking about 5 plus 5 plus 2, or thinking about 7 plus 3 plus the extra 2,
Mm-hmm.
those are additive strategies that we would want to nudge kids towards. We would want to help students develop those additive strategies to think about a problem like 5 plus 7. Because then they'd be thinking more sophisticated than counting by ones. And that's our goal. Our goal is to develop all of us into more sophisticated thinkers. Cool. So what would that look like with subtraction? Like let's just throw out a subtraction problem, because I just said earlier, subtraction lives within that additive reasoning sort of oval on the graphic of development of mathematical reasoning. So if I gave you a problem like 15 minus 8,
Okay.
15 minus 8, what would we expect to see if a kid is solving that using a counting strategy?
So 15 minus 8, they could start with 15 and simply count back 8. So 15, 14, 13, 12, 11, 10, 9, 8, 7, knowing that the number they landed on was kind of their in count, but still counting by ones.
Totally cool. And another strategy might be a kid who, instead of starting with 15 and lands on the 7,
Mm-hmm.
might say 15, 14, like you sort of said 15, and then kind of subtracted from there and landed on the 7. A
Sure.
kid also might go 15, 14, 13, 12, 11, 10, 9. So the answer's 8. So there's kind of two different ways they can count back. Sometimes people make a big deal about those two different ways of counting back. We kind of don't so much. As long as a kid is sort of counting back successfully and they kind of, well, or unsuccessfully, at that point, like when a kid is using that counting strategy to solve something like 15 minus 8, we want to then help nudge them on to using additive thinking. How can they use bigger jumps of numbers than counting by one? So,
Right.
Kim,
Yeah, I'm
15.
actually going to dive in because I think you said so the answer's 8. And I think what you meant was if they start with 15,
Oh,
they're counting the counts and not where they land. I was with you. I knew what you meant.
well, dang, did I really goof that?
Yeah.
Oh, I don't remember. So what I should have said was 15, 14, 13, 12, 11, 10, 9, 8. So
So
the
they
answer's
count. Yeah.
7. Yeah. And so do you know what I did that time? You all can't see. But the time before, I did it all in my head. This time I literally put up fingers until I
Right.
had 8 fingers up.
And kids actually do that, right? And
Yeah.
but sometimes teachers say, no, you have to count this particular way,
Mm.
which is not
Even,
true.
even though there are two fine counting
Right.
strategies for
Right.
solving 15 minus 8, and obviously I don't do one of them well in my head.
Right. Right.
But I did. Hey, I did it great once I had my 8 fingers out, and then I could see the 7 left over. Anyway, fine. Okay, so those would be counting strategies
Right.
for 15. Hey, it's
Right.
real, folks. This is a real podcast. That's really talking. So, we could use a counting strategy to solve 15 minus
Sure.
8. Kim,
Right.
what would it look like? What would we see a student do where we would go, this student is using additive reasoning to solve 15 minus 8?
Sure. So they could know that the 8 is composed of a 5 and 3. And so somebody who's thinking additively might start with a 15, remove the 5 to get to a friendly number of 10,
Mm-hmm.
and then remove the last 3 to get to 7. That's
Bam.
a way to think about removal with an additive strategy.
Yeah, and you removed bigger jumps of numbers
Mhm.
than one at a time. You removed that
Sure.
whole 5 all at once, and then you knew 10 minus the leftover
Right.
3. And those big jumps, that's additive reasoning. And so we're trying to acknowledge that we want to help students move to using more bigger jumps of numbers and less jumps one at a time.
Yeah. Well,
Additive
and,
reasoning,
and
not
can
counting.
I give you one more, because
Sure.
all those examples that we've been talking about are removal, but a kid with some strong additive thinking might also think about the distance between those two numbers and might say, I'm going to start with 8 and I'm going to think about 2 more is 10 and then 5 more is 15.
Yeah, and the idea that subtraction can have two different interpretations, that I can either remove the 8 or I can think about the difference from the 8
Mhm.
up to 15.
Mhm.
That's an important thing that we need to develop in students so that we have a robust sense of subtraction as kids develop additive reasoning. Yeah, nicely done. I'm glad you brought that up. So, do you reason additively when given a problem? So, could I give you a problem like, here comes a problem, ready? If I give you a problem like 57 plus 5, go ahead and solve that. Maybe pause a little bit. 57 plus 5. What are you thinking? Are you kind of nodding your head, saying to yourself, 57, 58, 59, 60, 61, 62? Are you counting those 5 by ones? Okay, if you are, you're thinking additively. All right, No, no
Counting,
harm, no foul.
counting,
Okay.
counting, counting, counting.
God, what did I
Sorry.
do? Did I just say additively?
Yes.
Man, I'm losing my
It's
mind.
okay.
Okay.
I'm listening to you.
You're thinking in counting strategies if you were counting by ones.
Yeah.
Okay. So that's that no harm, no foul. That's where you are on the
Sure.
development of mathematical reasoning. Keep listening to the podcast. Let's get you thinking more additively. So Kim, if I say 57 plus 5, what would a more additive strategy look like for 57 plus 5?
Yeah. So we're thinking about bigger chunks of number, right? So if I'm at
Mm-hmm.
57, I might want to get to a friendly number and add 3 at a time. So 57 plus 3 is 60, plus the remaining 2 is 62.
Nice additive reasoning. All right, let's give it another one. What if I said 42 minus 6? 42 subtract 6. Everybody solve it, listeners? If you're thinking about backing up by ones, then you're thinking in counting strategies. Kim, what would an additive strategy look like? Just one additive strategy for 42 minus 6.
Let's go with 42 minus 2 is 40. And then 40 minus 4, knowing that group of 4 back, would be 36.
Nice. Bigger jumps of numbers than counting one at a time. And remember, listeners, that the upshot is you might be like, Pam, I can count so fast by ones. I get the answer. I'm good.
Right.
Right. But if you're not thinking in terms of those bigger jumps, it's going to affect your ability to think about more and more sophisticated mathematical concepts as we go. And then you're going to be stuck with only being able to do less sophisticated thinking, like mimicking rules and procedures.
Can I pipe in for just a second? Because we have a colleague that has said to us before that she does some counting a little bit because
Mm-hmm.
that's what she grew up in.
Mm-hmm.
And that every once in a while she will find herself counting.
Mm-hmm.
And she has to stop herself because she knows that the goal is to build her reasoning. And so if you find yourself continuing to allow yourself to count because you're fast at it or because you've become good at it, then you're not developing your own reasoning, right? So when you catch yourself, stop, say, I'm not doing that. It reminds me of you in the grocery store. Long
Mm-hmm.
ago, you've mentioned the story that you would start to line numbers up and then you've almost pulled the numbers apart because you had a goal that was different than just getting an answer.
Exactly. I wanted to build my brain into being able to think and reason about more and more sophisticated
Yep.
things. Y'all, it took longer for me to solve problems for a while. I'm not even going to tell you how long until my brain got more, until I strengthened those neural connections
Right.
and they got stronger, and then they became my go-to. So it
Right.
might take you a hot minute to get your brain to have the connections be your go-to strategy. That's okay. Like we would recommend that you put in that effort to get your brain thinking, and spend the time to actually, okay, what would I do? What are bigger jumps of numbers? So that you can build your additive reasoning so that then more and more reasoning can become accessible to you because your brain's ready for it. Your brain is, you have more neural connections to build on. Yeah, totally cool.
So in episode 5, you delivered this fabulous gift to the world of a free workshop. And I'm super excited that now this workshop is available anytime, right? It's
Anytime.
anytime.
Woo!
So you can register, you get 6 weeks of access. Anyone can register. But when your 6 weeks is up, you can just register again anytime you want to. There used to be periods of time where it was available. Now it's anytime. So if you're a pre-service teacher, absolutely for you. If you lead book studies or PD in your schools, your PLCs could study it. That's absolutely for you. In fact, there have been some interesting ways that schools have used the DMR workshop, haven't there been?
Yeah, check it out. So when we first put it out for free, we had people come to us and say, okay, so we totally want to use this free workshop, but could you help us spark people's interest in our district before we just say, hey, everybody go do this thing? Could you spark? And so we offer actually some things around the development of mathematical reasoning free workshop where you could have me do a virtual, We call it a spark session now because that's literally what the first group asked for. Hey, can you help us spark some interest? We can do a spark session virtually on Zoom where I meet with your people and I give them some ideas about what's going to happen in the free workshop. I get them excited, use the energy and the Pam woo woo kind of thing. And people are like, whoa, this is interesting. And she's actually not going to bore us to death. And then you have your people dive into the free workshop again, because now you can register anytime. We can also do a live Q&A at the end. So we have whole packages that we can sort of put around the development of mathematical reasoning workshop. If you're interested, feel free to contact us. You can go to the website and go to the Book Me link, and then you can just sort of ask, hey, we want to do some stuff to use that free workshop to its highest advantage in all those ways that Kim just sort of talked about.
Absolutely. If you want to know about the development of mathematical reasoning, then you should check out the free workshop. You can find that at mathisfigureoutable.com/workshops.
Yeah, and we'll put that link in the show notes. So, if you want to learn more mathematics and refine your math teaching so that you and students are mathematizing more and more, then join the Math is Figureoutable movement and help us spread the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.